Hey everybody, it's Jason with Parallel Reality coming back with you here today with an article I think I found on Twitter. I don't remember where I got it, but pretty sure it was Twitter, X, whatever the hell you want to call it. I think we all know what we're talking about when we say Twitter. It's from September 11th. It is from NASA, the NASA website. It says Webb discovers methane, carbon dioxide, and atmosphere off K1218b. That's the James Webb Telescope, which is like the Hubble on crack, and K1218b is an exoplanet. So I'm always interested in alien sort of stuff, and I think this is more realistic than, the people saying that they see aliens here on the planet. I've always kind of said that there will be proof of alien life, I think definitively by 2040 at the latest. Not that I have any sort of background on that or anything to really think that, but it just seems like the way our technology is advancing here, and especially with stuff like the James Webb Telescope, we're going to be able to at least know, like, at least see, what do they call, like, microorganisms, on other planets. I think we'll be, or even maybe on our one of our moons, like Titan or something, hopefully in the near future. So that's what I mean. I'm not talking about necessarily like, human beings or alien like things like from Independence Day or whatnot. But I mean, something that at least say, like, yes, life can bloom elsewhere. So let's go ahead and see what this says. This is a pretty cool picture here, an artist's conception of the planet, which is this guy right here on the right. So the NASA article, not picking that out, says a new investigation with NASA's James Webb Space Telescope into K1218b, an exoplanet 8.6 times as massive as Earth, has revealed the presence of carbon-bearing molecules, including methane and carbon dioxide. Webb's discovery adds to recent studies suggesting that K1218b could be a Hycean exoplanet, one which has the potential to possess a hydrogen rich atmosphere and a water ocean covered surface. And also, is carbon dioxide? Yeah, no, it is a natural thing. Never mind. I was going to say, like, doesn't that mean like something's happening? On the planet, but again, I don't know this stuff like the biology or chemistry or whatever the hell. So let me know if you ever listen to this. It says the first insight into the atmospheric properties of this habitable zone habitable zone exoplanet came from observations with NASA's Hubble Space Telescope, which prompted further studies that have since changed our understanding of the system. It says K1218b orbits the cool dwarf star K1218 in the habitable zone and lies 120 light years from Earth in the constellation Leo. Exoplanets such as K12 or K2, 8, did I keep calling it K12? I mean K2, K2 18b, which have sizes between those of Earth and Neptune, are unlike anything in our solar system. This lack of equivalent nearby planets means that these sub-Neptunes are poorly understood, and the nature of their atmospheres is a matter of active debate among astronomers. The suggestion that the sub-Neptune K2-18b could be a Hycean exoplanet is intriguing, as some astronomers believe that these worlds are promising environments to search for evidence for life on exoplanets. And I imagine it's going to be exponentially tougher than, searching for life here, like on Mars or Titan or something like that, because those are really far away. So our findings underscore the importance of considering diverse, habitable environments in the search for life elsewhere, explained, I'm going to butcher this name, Niku Madhusthet. I'm sorry, I'm going to call you Niku and just call it that. An astronomer at the University of Cambridge and lead author of the paper announcing these results. Traditionally, the search for life on exoplanets has focused primarily on smaller rocky planets, but the larger Hycean worlds are significantly more conducive to atmospheric observations. Well, that's pretty cool. So this telescope can actually see it. That is cool. That is really cool. It says the abundance of methane and carbon dioxide and shortage of ammonia support the hypothesis that there may be a water ocean underneath a hydrogen-rich atmosphere in K218b. These initial Webb observations also provided a possible detection of a molecule called dimethyl sulfide, or DMS. On Earth, this is only produced by life. Oh, there we go. So it seems like we're heading in that direction. Says the bulk of the DMS in Earth's atmosphere is emitted from phytoplankton in marine environments. And then just a atmospheric composition graph here from the exoplanet itself. So we'll skip past that because I'm not smart enough to go over what that says on there. It says the interference of DMS is less robust and requires further validation. Upcoming Webb observations should be able to confirm if DMS is indeed present in the atmosphere of K218b at significant levels, explained Niku. That's what I'm going to call you again. It says the K218b lies in the habitable zone and is now known to harbor carbon-bearing molecules. This does not necessarily mean that the planet can support life, that the planet's large size, with a radius 2.6 times the radius of Earth, means that the planet's interior likely contains a large mantle of high pressure ice, like Neptune, but with a thinner, hydrogen rich atmosphere and an ocean surface. Haitian worlds are predicted to have oceans of water. However, it is also possible that the ocean is not too hot to be habitable or be liquid. That's pretty amazing. Although this kind of planet does not exist in our solar system, subneptunes are the most common type of planet known so far in the galaxy, explained team member, again, I'm going to butcher this name, Subhajit Sarkar of Cardiff University. Again, apologize if I said the name wrong. We have obtained the most detailed spectrum of habitable zone subneptune to date, and this allowed us to work out the molecules that exist in the atmosphere. Is characterizing the atmospheres of exoplanets like K2-18b, meaning identifying their gases and physical conditions, is very active in astronomy. However, these planets are outshone, literally, by the glare of their much larger parent stars, which makes exploring exoplanet atmospheres particularly challenging. The team sidestepped this challenge by analyzing light from K2-18b's parent star as it passed through the exoplanet's atmosphere. K2-18b is a transiting exoplanet, meaning that we can detect a drop in brightness as it passes across the face of its host star. This is how the exoplanet was first discovered in 2015 with NASA's K2 mission. This means that during transits, a tiny fraction of starlight will pass through the exoplanet's atmosphere before reaching telescopes like Webb. The starlight's passage through the exoplanet atmosphere leaves traces that astronomers can pierce together to determine the gases of the exoplanet's atmosphere. It's amazing what technology can do, isn't it? That it can actually, we can see a planet or at least detect things on a planet that is 120 light years away. I'm just fascinated by that. So this result is only possible because of the extended wavelength range and unprecedented sensitivity of Webb, which enabled robust detection of spectral features with just 2 transits, said Niku. For comparison, 1 transit observation with Webb provided comparable precision to 8 observations with Hubble conducted over a few years and in relatively narrow wavelength range. These results are the product of just 2 observations of K2-18b, with many more on the way, explained team member, again, gonna butcher her name, Savas Constantinou. I didn't do too bad on that one, of the University of Cambridge. This means our work here is but an early demonstration of what Webb can observe in habitable zone exoplanets. So the team's results were accepted for publication in the Astrophysical Journal Letters. The team now intends to conduct follow-up research with the telescope's MIRI's MIRI. I was going to say just MRI. So it's mid-infrared instrument spectrograph that they hope will further validate their findings and provide new insights into the environmental conditions on K2-18b. The ultimate goal is the identification of life on a habitable exoplanet, which would transform our understanding of our place in the universe, concluded Niku. Our findings are a promising step towards a deeper understanding of Hycean worlds in this quest. Yeah, this is incredible. So, I mean, just with this telescope, I mean, even go look up some of the images. If you do like a Google search, like James Webb Telescope images, you're going to find things that look like AI that aren't. I mean, it's amazing the clarity. Oops, fat fingered a button there that you can see with this thing. It's nuts, and you can see on the side here. There's a whole bunch of pictures as well. So I will have this article linked in the comments below, or not in the comments, but in the description below. So definitely check it out. So what do you think about this? Do you think we're getting closer to discovering alien life? How long do you think it's going to be? Do you think my prediction may be spot on, like by 2040? I mean, we've got 16 plus years to do that for my prediction to be right. So let me know what you think. Let me know your thoughts in the comments below. Like, share, subscribe, and I'll talk to you soon. Bye.